Hi, nice to meet you. I'm Avi. Today I want to go over how to get your agents to production and what it takes to secure them once they are in production and why you need AI to test against various things and go. And before that, I'm Avi Golan. I'm leading the product and engineering at Alice. And I'm sure you're all thinking, who the F is Alice? But before that, that's what we're going to cover. So talk a little bit about the challenges that enterprises are facing in today's world, and then talk about a few ways of dealing with that and what we're doing around that. But let's start with who we are and what we do. Private company, around 400 people. We're working with a lot of the leading labs, helping them to secure or harden the models, and also with many enterprises, helping them to get their agents to production and securing the agents once they get to production. Those are some of the companies that we work together with, and let's dive into the topic of what it takes to get your AI agents to production, what it takes to keep them secure, and this is like an evolving challenge that I'm sure is on top of many people's mind. Um, uh, but but if you go to the basic of what is a large language model, it's basically trained on all the data that's on the internet, right? And this is there's good data, but there's a lot of really bad stuff out there, and both from people that created the data that the models are training and learning from. But this is not something new, right? This is something that since the early technology revolution days, that every era had its own issues and its own problems. But in today's world with AI, it's just like the problem got a lot bigger, a lot faster. The scale, the capacity of the problem, of the challenge, got a lot bigger. And in today's world with agentic, right, when you don't need people or humans, bad actors can take advantage of that and really scale that operation. And this is the results. Like this is stuff that I'm sure many of you already seen, um, um, uh, screw ups that happen to companies and issues that cause PR, but issues that spread around, harms that spread from different categories, from fraud to deepfakes to human trafficking. So bad actors use this technology to do bad stuff, right? And this leads to this stats that most of the enterprise, or many of the enterprise, fail to get their agents, their GenAI-based applications, to production. And this is due, a lot of this is due to the fact that it's hard to keep them secure, to keep them safe, and even to test for that and better understand what's the security or what's the risks that are involved in doing that. And those are some examples that we pulled from from the last year. And this is the first one is Chipotle chatbot that was used for not for his original purpose, which was for tracking orders and stuff like that. But someone found that he can use that as a coding agent and then open source that so other people can also use the Chipotle chatbot for their own coding purposes. So that's it's money and a PR issue, right? But this is something that is a little bit more severe, where this is like a chatbot by a university that said that he's a licensed therapist and gave advice to someone, and then this university is now exposed to legal actions. And this is something that is, I don't know if you've already seen that, but this is like a chatbot by Chevrolet basically a customer asks them, like, which car should I buy? And then the chatbot is saying Tesla, which is, again, it's not a cybersecurity, but this is like a brand and PR damage that you want to protect against, and you want to make sure that it doesn't happen to your agents or your products. And it doesn't stay only on the virtual world. It sometimes unfortunately gets also to the physical world, where this is like a case where Google and the company that Google bought, Character AI, was sued because of that. So this is a taxonomy that we built based on some open source taxonomy like OWASP and others. Just to lay out like the landscape of the challenge, right? This is like all the risks. I'm sorry for there's like some overlap here on the presentation, but it's spread around like two main areas. One is the security, which is basically you want to protect your model against bad actors, and the other side you have the safety, where you want to protect your users from data or from actions that the model might be taking. And as you can see, like it's spread around like a lot of different areas that you need to take into consideration when you deploy those agents, your agents into production. You want to make sure that the stuff that you're doing or building is in compliance and following the regulation and following the policies that you have as a company. And the problem becomes bigger because there's no single owner in the organization for that, right? Because it spreads across different areas in the organization. There are many different stakeholders, ranging from security to privacy team to the product and engineering teams to the legal teams and more. And then it's not really clear who owns that problem end to end, and there's a lot of overlap between all those different organizations and different responsibility. And again, it's really hard to determine when there is like a data leakage in some financial institution that was caused by a chatbot. Who's owning the problem, right? Is it the security? Probably yes, right? This is like a data leakage. Is it the product? Also yes, right? This is like, the product team should have made sure that the data is secure and they have the right capabilities in place. It's also a legal issue. So there's many different stakeholders. Usually when we are talking to enterprise, that we see like different organizations, mostly committees, that are in charge of that. But this is something that you need to think about when you're building your AI operations. So we mostly talked about Gen AI-based applications, but now with the Agentic era, this is like the problem becomes bigger, right? There's now tools and the agents can take actions, MCPs, and so on. Can do web calls and so on. So we're now expanding basically the attack surface. We're moving from this space where you had those chatbots that were connected to some wiki page or whatever to almost fully agentic autonomous agents that take actions on your behalf. And those are another couple of examples on the agentic side where you had failures due to agentic behavior of the products that we're using. On the right side, you have a GitHub Copilot that had like an indirect prompt injection by a security researcher that caused the agent to do whatever the attacker wanted to do. And on the left side, this is like an incident that happened with vibe coding platform that chose to delete the production database. So again, the problem now becomes bigger as the tools expand or the capability expands. And this is like a layout of the different risks that are out there, or the ones that you need to think about. And now, on the outer layer, you have the new agentic specific kind of risk, which is like you have now models that can reason, so they're now exposed to reasoning manipulation and tool calling attacks and more. But all of that is not replacing the previous kind of risks that you had. Is just like added on top of it. It's been added as another layer, another kind of risk that you need to be aware of, you need to be test for, you need to protect against, and you need to consider as you go through your development lifecycle. And this is a nice framework that I often go to when I think about how to understand the risk. It's called the little trifecta it's by a security researcher called Simon Wilson, that basically says that you have three capabilities that you need to think about when you're designing an agent or when you're trying to assess the risk of an agent. One is like, does he have access to untrusted data? So untrusted data can be the user prompt. It can be data that comes from a website or from other data source. So that's one. Second one is the sensitive data access. So does he have access to your employees' table or to your customer table or to whatever salary data and so on? And lastly, you have the tool calling. So things that can make an action, so can change a state in the database, can send an email, can do something. So if you just have one, let's say the example from before, a chatbot that is connected to a wiki, the risk is not very high. Like, the worst case is that it will give the wrong answer. But if it's connected to, to a table with some PII data, and then he has access to send to use a tool called to send an email, then you can have an attacker that leverage all of that. It doesn't mean that you need to remove one of those categories, because then you basically crippling the agent or making it not function as the way it should. It just means that you need to think about the risks associated with combining all those capabilities together. So I want to talk about some practical things that you can do in order to get to production faster and safer. And sorry for the overlap there. Something messed up with the slide. But I want to break it down to three categories. One is the pre-deployment controls that you might have. Usually, people do model evaluation, like check the model, the model that they want to work with. They do some red teaming. They might do pen testing. And once they get to production, they will have guardrails. They might deploy some observability. And then they have those post-deployment governance kind of controls. It might be human in the loop that sample the data or checks for violations and so on. And if we double-click on the pre-deployment controls, which are basically before you go to production, what companies are usually doing. So they will start with like getting the model card from the vendor, and checking how they tested for the model. But this is more of like trusting the model provider, and then they might use their app, the security app team, to run some red team exercise on your agent. But that's like, it doesn't scale. That's like humans that are doing the process. You might run some automated scanning of known prompts, known attacks. You might take some benchmark from some company that evaluated different models, but that's something that is like mostly generic and not based on your use cases. You might run some pen testing, which tests for the system, like API security issues and stuff like that. And you might, employ some keywords detection and check for rules that you might have. But all of that is more around like the outside of the application, right? It doesn't really test for the non-deterministic behavior of the model, which is what you want to test for, right? This is what what the pen testing tools or capabilities doesn't cover, which is it's like the non-deterministic behavior of the model, which is every character or every combination of character or pixel in an image can transform a prompt from being benign to being violative, right? Or from a response or create a response that is problematic or against the policies that you have. And this is the thing that you want to test for. You want to make sure that someone, like it might be an adversarial user or a benign user that makes a mistake, doesn't cause issues. And issues might be around the safety, it might be around security that you want to minimize or protect against. And this leads to what's called AI red teaming or adversarial evaluations, and it's basically, that's the definition: proactive adversarial testing of AI systems to identify security, safety, and ethical risk before they reach production. So, and I want to focus on a couple of things. So, proactive means that you do that before you go to production on your testing environment, your staging environment, wherever it's part of like your software development lifecycle. And adversarial, so it's like it needs to think like someone that is going to attack the system, someone that is going to do harmful stuff. So that's like the key aspects of like what a red teaming exercise will look like. And going back to the taxonomy of the security and safety, it needs to cover all of that, right? It needs to cover all the aspects that are important to you, whether it's like regulation and compliance, like stuff that you need to adhere to and follow, or things that are policies that are related to your companies or defined by your company that you want to check for. And this is like how an automated red teaming exercise will look like. It starts with on the left side with a threat modeling, which is basically understanding the agent, how it behaves, what is connected to the system prompt, the tool access, and all of that, and then mapping the potential threats. And then we go to the attack planning, the second one, which is trying to come up with scenarios, adversarial scenarios, that will be relevant for that specific agent and can be used in order to do the attack. And in the middle, we have the red teaming execution, which is basically like running a single turn or multi-turn kind of interactions with the target agent in order to simulate real users' behaviors. And once you get responses from the agent, you do evaluations. So using frameworks, using LLMs and frameworks to evaluate the response and see whether or not you were successful. And based on that, iterate and come up with the next version or the next set of tests. And then combine everything into assessments and findings that can help you improve the posture, can provide you with guidelines on how to fix it or how to improve it. And this is like an iterative process. This is how we're doing that. It's we're basically deploying agentic red teaming agents that interact with your system, simulate real user interactions, and continuously evolving based on the feedback that they're getting from the system, and then deciding on the next step, deciding on how to improve the attack or how to find better techniques that can bypass some or punch holes in the security and safety. So lastly, I want to leave you with a couple of thoughts. One is that there's like an expansion of the attack surface, It's moving fast. There's ambiguity around who owns that, and there's like the system without the human in the loop. All of that like contribute to the problem and to the expanding risk. And take away, you're basically now testing for you're not testing for the system, you're testing for behavior. So think about that as you design your system, as you design your test, and executing that both in the testing phase and also when you go to production.